Hello, 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 and welcome to another day of LeetCode Live, where we do daily LeetCode streams for all of your grinding and practicing needs. So today I'm pretty excited to announce that we are starting on our third page of LeetCode. We have come pretty far in our journey, so it's pretty cool to see how far we've come, and it feels really good to also say that we're finally on this third page. There's, I think, how many pages total? There's 5 pages total of the easy questions. Now, I display 100 per page, so just by that, you know that we haven't done every single one, right? It looks like we're missing about 32 questions since the beginning. These are questions that were either just rated terribly or maybe, like they were just really weird to solve, or perhaps I just didn't know something at the time of how to solve it. So I typically try and save those for the weekly roundups, which is every Saturday of every week. We just go over previous questions that we hadn't solved for that week. So without further ado, let's jump right into it. Let's make this hour worth it, and let's see how much we can solve. All right, so starting off here with count largest group, looks like another terrible question to start us off. And I say terrible because this like to dislike ratio, it's not very good. But let's see what we can get here. So we are given an integer n. Each number from 1 to n is grouped according to the sum of its digits. Return the number of groups that have the largest size. Okay, there are 4 groups with the largest size. Okay, so we're given integer n. Each number from 1 to n is grouped according to the sum of its digits. Oh, I see. So 1, okay, so we go from 1 to 13, and we return every single one of them that has the largest size. And I guess there's 4 of them here that have size 2. Only one of them has size 1. Okay, so I think what we can do here is really the only way of doing this. I mean, we can go through each one. We're going to have to, for each array, let me see, this is 3, this is 3, 4, 4. We're going to have to, for example, so we'll have to loop from 1 through n, right? For each number, calculate sum of digits, store in map, where we can do, let's see, sum of digits to number, right? I think we can do something like sum of digits to the number, something like this. And then at the end, what we can also do is during that time, we can also store the size. We can also store the size of the thing. Yeah, anytime like we push, we get the new size, and that's going to become our max size. So after push, get new max size, return amount of arrays with this size. So I think this is a pretty good way for us to go. So let's start with our loop, right? So we're going to go from let I equals 1, I less than or equal to n, I plus or equals, or we can just do I plus plus. I want to get, let's see, we can say const calculate or get sum from digits. We can do get sum equals, let's see, we can just say num, right? And here we'll have a variable called num, set that equal to 0. We'll say while num is not equal to 0, we can get a digit that's going to be equal to 10. Sum plus or equals to digit, and then num is equal to math.floor of num divided by 10. So this is just like a trick that we can use to be able to pick each individual digit off a number and then get the sum. And here we just return sum. So 1, 0, we'll get the sum of all these. So then what do we return here? Now we want to create this store and map, right? And here we can say const sum map, set that equal to an object literal. Now we can get the key, right? So our key is actually going to be get sum of I, and we can say sum map, or if, we can say if sum map of key is equal to undefined, right? That means this is the first time we see this key. Then we'll say here sum map of key is equal to an empty array, and then we'll say sum map of key dot push I. And we can say let max size equals, we can just say 0. We can say max size equals math.max of max size or sum map of key dot length. And now really all we need to do is at the end, now we'll have all these different sized arrays. So we should just be able to say, let's see, for max size, and this is how many? Largest group. Largest equals 0. We can say for const, instead of value, we can say, let's say const nums of object.values of sum map. This will, nums should be an array here, so if nums.length is equal to max size, we can say largest plus or equals 1, and then we'll just return largest down here. So let's see what this gives us. Kind of like went through this one really quick. 4 and 4. See what we have here. 4 and 2, 4 and 2. All right, let's submit it. Are we gonna get off to a great start right here? 89.39. That's really nice. I'm really happy about that. Let's go over quickly here to see what we did. Or actually, let's see what we did, right? So I go from 1 through n, just like it says. For each digit, I need to get the sum of its digits, right? So this formula right here, this is just not really a formula, but this algorithm is just an algorithm that we can use to pick off each individual digit of a number. And then this way, once we get the sum, that essentially becomes the key of this sum map. So my key in this sum map will be the sum, and then every number will be the number that got us that sum, right? So it'll be sum 1 equal to all these numbers, sum 2, so on and so forth. Every single time we push, we also update this max size. That way we know the size of the largest array that we've seen. And then at the end, we can just loop over all the different arrays, and that's gonna be what the largest one is. Now I wonder if, like, can I actually do this without, like, if I see 1, as soon as I see 1, maybe I can just have largest be 0 here. Or like, let largest equals 0. So let's see something here. If, let's see, if we do like, if sum map of key dot length is greater than max size, largest equals sum map, or largest equals 1, and max size equals, or actually we can do sum map equals 0, max size equals sum of map of key dot length, and then we do largest plus largest plus or equals 1. Can I actually just do this instead? What I'm trying to do is like not have to also loop through my keys right here, because I think what I can do here is like at every single point, like let's say we have a max size already, right? Anytime that it's at least that size, or wait, do I always want to add if it's less though? Because like, what if it's less? It needs to be exactly that one, right? If it's greater than max size, we make it 0. If it's equal to max size, maybe, yeah, only if it's greater than max size, we can make it 0, because that means now there's a new one. Max size equal. If it's equal to max size, what if we also did if some greater than or equal? I know this looks kind of weird. I'm just trying something out here. Can we actually do this? 4242. What happens if we submit this? Wow, okay. I wouldn't have expected for that to actually run slower than the previous one, because now I'm not even doing this loop in the bottom here anymore. 80.30. I'll necessarily need to do this, right? Like I can't get away from doing get sum. Max size is 0. that's fine. Let largest, that's fine. If it's undefined, let me just make this all a little bit nicer. Right, so if it's greater than the max size, so if we're at a new array that's greater, that means that we set it equal to 0. If it's greater, it's 0. If it's greater than or equal to, then largest plus or equals 1. Yeah, there's like a very simple logic thing here that I'm not doing right. Because like what happens if we get to a 1, now we get to a 2. This is the new largest one, so we should reset largest to 1. Now if I see another one that's 2, right, I only want to say probably only if it's equal to max size. If it's greater, make it to 0. Max size equals that. How about this? 4242, still probably the same. 83.33. Yeah, either way, I'm pretty happy with this. Let's try to think about the time complexity here. Let's do an analysis real quick. So this is linear, right? I mean, it's weird because sometimes people say, like, if I know this is bounded by some amount of numbers, it might just be constant because it's never going to go past this. But I guess with that saying, like with that reasoning, wouldn't anything be constant because it will necessarily have an upper bound, at least on LeetCode. So here, though, this is linear because we're going to go through every single number. So this is n. This algorithm is log n time because for every single step, we're essentially like reducing the size of our input here, right? By a factor of 10. So it's sort of like log 10, I guess, or I'm not really good with logarithms. I don't want to say something that's completely wrong. So this will be n log n, right? It's going to be n times this get sum right here. And then everything else in here is going to be constant. These are just constant sum operations. So the time here is going to be n log n. And our space complexity here, since we're doing this sum map right here, this is actually going to be linear as well. So it'll be a space of O of n and time complexity of n log n. Let's see what discussions have to say here. Java count 37. Is that going to be the biggest that we have here? Dsum. Okay, so this is just the same thing that we did. Max or the dsum, some crazy looking code. I find it hard to understand the question. I need help. Python dp. The idea here is that we can save on calculating sums of digits for bigger numbers if we start from 1 and keep the results in dp. Quotient remainder. Brilliant solution. Nothing but a dp solution to find sum of digits. Nice. That's funny. Sweet. Yeah, I'm happy with this. We can go ahead and resume. That's nice. It's a nice way to start off on the third page with, like, even though it was not a top quality question, it's still nice that we were able to solve it, and in a good amount of time too. All right, the complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to 0 in its binary representation. For example, the integer 5 is 101 in binary, and its complement is 010, which is the integer 2. Given an integer num, return its complement. So what is the, okay, 2 to 31. So I mean, I think one way of doing it, and just to make sure, like if I flip, what if I just do it with like a really big number? Because what will flip, let me see something. If I do 0, I want to do the truth table for XOR, which means exclusive OR, right? That means it should only ever be 1. It should only be 1 if it's 0. So if I want to make a 1 to a 0, 1 will become a 0 if I XOR it with 1. 1 and 0 will be 1. That wouldn't be a 0. If I do it with and 1 and a 0, or 1 and a 0 will be 1. It wouldn't be the opposite. What if we is the negation no leading 0 bits and its complement is 0? Can we just do this in one go? Or I can also just say a 1 to 0 and a 0 to a 1. If I want to make a 1 to a 0, if I toggle it with 1, oh yeah, right, if we just do a 1 to a 0, if I toggle it with 1, that'll equal 0. If I toggle 0 and 1, that'll equal 1. Yeah, I think we can just XOR it with 1, right? Because 1 XOR 1 equals 0, and 0 XOR 1 equals 1. Yeah, so we can just toggle it like this. Now, what if we toggle every single number with a large, like, can we just create 1, 2 to the power of 31? Like, if I just created a mask, would it actually work that way? If we did, like, const mask equals, what's up, Rafael? I hope you and your family are doing well. Thank you so much, Rashawn. I really appreciate it. Always glad to see you. Like, always glad to see you around here. You're definitely one of, like, the OG people that has been here since day one. So it's super cool to have you around. Thanks for joining. So what if we do, like, could we create 2 to the power of 31? Can I create a mask like this and then just return num mask? Will this set everything? I mean, let's just go for it, see what happens. Okay, yeah, that's wild. I'm just trying things out here because, okay, yeah, what is every single 2 to the power of 31? But like in binary, biggest positive will fit in 32 bits when using 2's complement. The way I represent numbers that allows for negative values. So how do we, or how can we, this is 32 bits. If it's a 1, as in the number is -2 147 648 to the power of 31. The 32nd bit that remains in our 4th byte or 32-bit number is used to represent whether the number is positive or negative. If it's a 0, positive or negative numeric values. I just want to see if we can do this by creating a mask of 31 bits using a 31 subnet mask. Maybe this is not even, nah. JavaScript. Bitmask 0 should return 1. Bitmask 32 should return in binary or decimal. Bitmask. You should consider using a different method like math.pow to obtain larger bitmask and higher values. Here's an example. 2 to the width minus 1. Okay, so we were kind of there. Unless maybe should it be this instead? 2 to the width minus 1 num mask. Oh man, I really thought we were like close. Thanks for the live coding. No worries. Yeah, absolutely. I really want to figure this out because I feel like we can get somewhere here. And if I just do this for fun, output 5 expected 2. And I think we already tried 31. That just gives us like a crazy number. You know what though? It's not that we want to negate it, right? All the 0s to 1s. It's only as far as the last one. Yeah. That's the problem here. Not really the problem, but like we don't also want to do, like if it's 0, yeah, if it's 101, that becomes 010. So it's only going to go up to the last set bit. How do we find the last set bit? I know I'm looking things up, but I think this is a good learning experience. Find last set bit. Position of rightmost set bit. For example, 121100. How do you get position of rightmost set bit? Third bit from the right, 0, 1, 2, 3. Okay. The answer, unset the rightmost set bit, tells both how to get and unset the rightmost set bit for an unset integer. Unset rightmost bit, why it works. and choose 8-bit for simplicity, though the idea is the same. Get rightmost set bit, an example for unset rightmost bit. Example for get rightmost set bit. But I don't want example for unset rightmost. How about from the left? Set bit, unsets the last bit, no. Find last set bit leftmost. Coding ninjas. Leftmost set bit. Initializing the position to 1 while n position, return position. Oh, is that just while n is greater than, oh wait, that makes a lot of sense actually. We're just right shifting it by 1 and we're increasing the position every time. So what if that became my width? Okay, so what I want to do is, like, if I had const num toString 2 bin, it kind of seems similar to what I was just looking at, but really what I'm trying to figure out is like the position of, let me see, so 1 2 3. So if we did, let's actually just do this for fun. So if we had 5, like we know 5, okay, so const x equals 5, 1 0 1, it's not equal to 0, not equal to 0, not equal to 0, wait, 1 2 3. So does that mean this would be const mask equals math.pow of 2 to the power of 3 minus 1, x XOR mask is 2. Okay, yeah, I think that could work then. So what if we did, let's see, const get leftmost bit. We're going to be given a num. Here we can say while, or we can say let position equals 0 while num is greater than 0, num equals num right shift by 1, position plus or equals 1, return position. It does, but I don't know if this question's, oh, what's up, by the way, Sam? I don't think this question's asking for all the bits. It's only for like I need to know all the bits up to a certain position. And that's what I'm going to try and do here. So if I said get leftmost bit, and then I said mask equals math.pow of 2 to get leftmost bit of num minus 1, can we then return num mask? There you go. Let's see, wait. So if I run this with all my test cases, 2 and 0, 2 and 0, 5 13. Okay, so yeah, maybe there's a faster way of doing this, because my thing was like, I was creating a mask of size 2 to the power of 31, but that's also going to flip all the I guess the leading zeros, but I only want to flip numbers up until the end. So what I was trying to do is find, do bitwise operations even get asked in an interview? I would totally bomb if I even got. Okay, so that does work. Does that really work? Because that's what I was thinking too, like the negation. Is it just that? Probably just that. -6 and 2. Yeah, this is what I was getting earlier when I was making my mask of size 31. Hey, what's up, VP? Yeah, like I've never been in an interview, and I did a lot of interviews this year. I did like 8 interviews, or yeah, probably like 8 interviews, and I was never asked a bitwise question. Wait, nanny. That's what Sam said. Wait, nanny. Yeah, because I tried doing that earlier, Sam, like getting, because I guess that would just do it. That would flip all the bits, even leading bits, but they only want it up until, Like after the 5 ends, I shouldn't consider all the other ones. So if I'm also making those ones, all the zeros ones, that's why I came up with this. Like, this is a cool trick. So yeah, like it makes a lot of sense when you look at it, but to get the leftmost bit, the position of the leftmost bit, we can just keep shifting num until it's no longer to zero, until it's no longer greater than 0, and every time we increase the position, that'll give us the position of the leftmost bit, and then we can create a mask that's as wide as that. Or we can create a mask that's as wide as that, and then we just do the XOR of our num with mask. So that was pretty cool. It's very weird that it runs that slowly. Let's see what this has to say. 3-line. Oh, there you go. Some other. See, like this is crazier. So find complement of num, unsigned mask. Okay, so we create all the masks while num and mask. Okay. Num, mask. Right, so it looks like, yeah, see, so I guess they're kind of doing something different where they're just negate, like they have the zeros on this side and there's zeros on this side. I guess we also did something similar. But I'm very happy overall with like, just depends on how many bits you want, but the number is already represented as bits without the leading 0. Is it actually? I don't know if it's actually represented that way or they're just telling me that it's that way without showing me the leading ones. I'm happy that I solved it like this anyway though, because again, I learned something and I feel like I can actually use this in other questions. So let's move on. I feel like we're doing pretty good in terms of, like we've done 2 questions. I know it doesn't seem like a lot, but so far they've been decent questions. So let's see this one. Alice and Bob take turns playing a game with Alice starting first. Initially, there's a number n on the chalkboard. On each player's turn, that player makes a move consisting of choosing any x with 0 less than x less than n and n modulo x equals 0, replacing the number n on the chalkboard with n minus x. This actually might be the worst question I've ever seen in terms of like to dislike. So choosing any x that's greater than 0 and less than n, and n modulo x equals 0. Returns true if and only if Alice wins the game. This seems like a question where the number is just like return n or something like that. I don't know why. That's the feeling I have. I almost kind of want to like try and guess. True, Alice chooses 1. I mean, is it just like return n modulo 2 equals 0? Well, that will, I think that's going to pass both test cases here, but I don't think it necessarily means that it's going to work. Just because, I mean, these are super contrived. I'm just going to try this for fun. I swear if this works. Like, I literally guessed that. I swear to God, I've never seen this question. I just know LeetCode enough to be like, this is one of those dumb questions where you just return something like this. I truly promise you guys, I have never seen this. It's just like, come on, LeetCode. Oh my God, that's so funny. That's hilarious. All right, cool. Let's see what we can do. Let's keep going. That was an easy one. I'll take it. Give me a second. Let me get some real quick. I'll be right back. right, so are we finally at a question where it's a good question? So far we've looked at mostly terrible questions. And when I say, I don't mean they're so terrible, but some are better than others. So, okay. Sort even and odd indices independently. So you're given a zero index integer array nums, rearrange the values of nums according to the following rules. Sort the values at odd indices of nums in non-increasing order, and sort the values at even indices of nums in non-decreasing. I don't know why they say, like, why can't they just say increasing order instead of non-decreasing? Okay, so we're just going to go backwards on both. And it's only for, let's see. Like if I were to sort this, I think, let me see something. 4, 1, 2, 3. Let's say I sort it 1, 2, 3, 4. And it wants me to sort values at odd indices in non-increasing order. So let me write the indices up here. 0, 1, 2, 3. Let me like 1, 2, 3, 4, 5, 7, 8, 6. I just want to make this a little bit longer to see. 7, 8, 5, 6, 7, 8. Okay. 4, 5, 6, 7. So here, non-decreasing values at even indices. These would already be. Oh no, they wouldn't. Well, yeah, in this case though, like we have 1 and 2. Well, we always start with, you're given a zero index integer array nums. Okay. 1. Odd indices. Oh, it doesn't matter the actual value. It just matters. Okay. So if we sort it like this, sort the values at odd indices and non-decreasing. So this will already be okay, right? Like if I sort it, I feel like this first part will already be good. Now I just need to do the same for the other one. Like what if we did, could I just swap starting from, wait, this is odd indices 1. So even should be in non-decreasing. So what if I started at 0 and 6 and I swapped these? So this became 6, or wait, 0 and 6, that's 1 and 7. So this becomes 7, this becomes 1. Then I go to 3 and 4. This becomes 5, and this becomes 3. I feel like we could do that. I mean, I feel like that's a way of solving it, perhaps. So let's actually give that a shot. So let's do const sorted nums equals nums dot sort a minus b. So like just by that nature already, this first part will be done already. 4, 1, 2, 3, or not that part, this part, non-decreasing. 2, 4, okay. Sort the values at even indices. So it's not the value, it's just like, okay, so I believe that's fine. So now for the next piece, sort the values at odd indices. So we can say, let's start equals 1. If there even is a 1, which there should at least be a 1. And then if it's odd, if we have an odd length array, 0, 1, 2, 3, 4, that's even, right? If it's odd, 0, 1, 2, 3, 4, I want to start at -2, so let odd equals sorted nums dot length modulo 2 equals 1. If it's an odd length array, then odd should be equal to sorted nums dot length -2, 0, 1, 2, 3, right? else if it's even. Oh wait, should it always be, even if it's even, 0, 1, 2, 3. No, if it's even, it'll just be the 1. So sorted nums dot length minus 1. We can say while start is, I don't know why I put, maybe this should just be end. While start is less than end. Give me 1 second, I'm getting. Okay, so while start is less than end, can we just start swapping these now? So what if we did here sorted nums, or no, we have to do sorted nums of start, sorted nums of end equals sorted nums of end, sorted nums of start. And we should just be able to do start plus or equals 2, end minus equals 2. I'm going to set that equal to equal. I'm going to make it less than or equal to just for, really just for no reason, just to see why. Just see what we can get. Let's now just return sorted nums and see what we get. I'm just going to go for it and then we'll talk about it. 1432. This is like completely wrong. Okay, wait. 1432. So let's see what happened here. Like we did 1, 2, so this should be 1, 2, 3, 4. It says the values, sort the values at even indices of nums in non-decreasing order. So should that not be 2 and 4? I might be thinking about this question in the wrong way, because sort the values of odd indices of nums in non-decreasing order. Oh, it's not like, I see. I think I know what we can do then. We can take sort the values of odd indices of nums in non-increasing order. What if I'm always taking like the maximum and the minimum? Can we do that? Weird though, because like this, 1 and 3, this is not right, because isn't the output here still valid? Sort the values at odd indices. Oh no, 1 and 3. Yeah, 1 and 3 in non-increasing order. 4 and 2. Okay, sort the values at even indices and nums in non-decreasing, 1 and 3. So isn't that, I mean, that does satisfy. Okay, first we sort the values present at odd indices. Oh, but it's not, okay, because my sorting is changing. Okay. 1 and 3 in non-increasing order. So let me think about this. I can't change. I just need to imagine that like, okay, I see. So in this array, in all these different odd indices, I should get the value. Like if I knew what the minimum one was, which maybe 1, 3, and it doesn't need to be 4, 1, 2, 3. Sort the values present in non-increasing order. So we need for this one to come first, 3 and 1. Now if there's another one, if there's like a 5 elsewhere, how do we know unless we just like, it seems crazy to sort of make like 2 different arrays. What if we just pull out all the odds, we sort those, We'll pull out all the evens. We sort those. And then we sort of like merge them together. Maybe that could work, but that seems like a lot. I can do one from even, one from odd, one from even, one from odd. Is there an easy way for me to create just the numbers? We can try it. No, we definitely can. That's for sure. But it's like, that seems like a lot. I have to first get all the odd. Could we sort, like, could we sort numbers? Or sort JavaScript, sort numbers in specific indexes. It gives the position, how to sort an array from a specific index. Sorts long. I mean, we can maybe make our own comparator. The first element and the second element. But that sounds, no, that's going to be a little bit tricky. What else do we have though? Let's see something actually. You know what? We have this array here. We have an array here. So what if we actually just, I think I know what we can do. I think we can do something better. Imagine we had, because now I know my upper bound is 100. It's a pretty small like size I have here. So what if we had 0, 0, 0, 0, 0, right? We have 1, 1. So we signify that putting a 1 here. We have a 2, we have a 3, and we have a 4. These are all the different values that we have. So sort the values at even indices of the nums. Yeah, sort the values of odd indices of nums in non-increasing order. Can this help me here? I have 1, and that's at an odd index, and this is 1. So this is the smallest one. I should put there. And then the biggest one from the back. Yeah, like as I'm going from left to right, the smallest one I find from the left should be the first one in the back. Okay, so like what if, yo, what's up, Marvin? Let's do this. Like what if I made result equal new array. I'm gonna make this size of nums.length. And I'm also gonna create const, let's see. I'll create another one called like const counts equals new array of 101. We're gonna fill this up with 0. Okay. Now we're going to do for const n of nums counts at n plus or equals 1. All right, so this will give us an array where every single number is represented by 1. Now we don't know, I guess I don't know that this is unique. These numbers are not unique. 2 and 1, does it say that they're unique? No, it doesn't. So that actually makes things a little bit more difficult. But I'm thinking that like, as I'm going from the left, let me think about this. Because I want, no, is that actually gonna work? Can we do that? Sort the values at even indices of nums. I also lose the positioning. I know that there's a 1 that exists, but is that number 1 in an even or an odd place? Sort the values of even indices of nums in non-decreasing order. nums in non-decreasing order. So I end up with 2, 4, and 3, 1. It seems to me actually like maybe we just want like the smallest odd at the end and the smallest even in the beginning. Although again, I'm getting caught up in thinking that like it's not the value that matters, it's the index that matters. Because like this doesn't necessarily have to be neat. This can be like a number 5. It's an odd number, but it sits at an even index. Nums change from 4, 1, 2, 3 to 4, 3, 2, 1. Sort the values present at even indices 0 and 2 in non-decreasing order. So nums changes from 4, 1, 2, 3 to 2, 3, 4, 1. I mean, I can also maybe take like the index where I found the number. What if I just had a list of all the evens and a list of all the odds? What's a quick way for me to get a number? I can have like an even set and an odd set. It'd be nice if that was an ordered set. I mean, we could sort this. I can create 2 sets of nums that are in even and odd indices. I can sort the array. But that's also not gonna. Even index and odd. Oh, this one's tough. This one's really tough. One odd index and one even index. Now rearrangement of values takes place. Stumped. So we have even index. We have even index. Both of these are from even indices, and we want a non-decreasing. So this should be increasing order. So we take all the even indices, we sort those. I mean, yeah, we could have an array, or we could have an array of objects where the object keeps track of like whether it was in an even index or not. Because then when I have my count of all of these different numbers, I can say, okay, like find the smallest even number and put it here. Find the next one and put it here. Well, we can do something that's really truly disgusting. Let's do that. This is what I'm gonna do. Odd indices, even indices. For let I equals to 0, I less than nums.length I plus plus. If I modulo 2 is 0, then even indices dot push nums of I. Else odd indices dot push nums of I. We want odd to be a non-increasing. So now we can say const, or we can say sorted even is equal to even indices. We're going to sort this in increasing order. We can say sorted odd equals odd indices. We'll sort this in decreasing order. And I think what we can do is we can take the smallest thing in even, and then the biggest thing in odd, and just alternate that way. So I can say const result, and let's see what I can do here. I'm going to create like a crazy looking for loop here. We're going to say let even equals 0. And then we have the biggest thing in odd, right? Okay, let even equals 0. Odd is going to equal sorted odd dot length minus 1. Even is less than sorted even dot length. Odd greater than or equal to 0. Even plus plus odd minus minus. Talk about a crazy looking for loop. Here we're going to do result dot push sorted even of even, and we'll push sorted odd at odd. Return result. I think you all, well, let me see what this even produces, and then I'll give you my my spiel here. Odd insides. Okay. Result dot push sorted odd of odd. What does it? Oh. Two 1 4 3. Aren't I starting in? Oh, I already. Oh wait, I can actually just even make this easier since they're both. Yeah, we can actually do it. Let's see. For let I equals 0. I think I could just do I equals 0, I less than nums dot length, I plus plus, result dot push, even and odd, because odd's already sorted and decreasing. Nums dot length. Wait, what? How are we getting 2 3 4 1 nums dot length? Is it only because we're not? Should I only go however much? Oh, because one of them might be less than the other one. So I think we should only. Okay. All right. We're gonna do like a classic merge then. But that's like a whole other. That's like a whole other operation. That sounds wild. Let's do let even equals 0. Let odd equals 0. While even is less than sorted even, and odd is less than sorted odd. You can say result dot push sorted even, and this should be dot length. This should be dot length. Sorted even of even. Result dot push sorted odd of odd. Can we just do this? Let me see if this will work. Or is it still going to be, of course, this question made me go crazy. This question made me go crazy. 2 3 4 1. I promise you this is not the most optimal way of doing this. Like 100% sure. 2 and 1. We'll submit it and see what happens, but yeah, okay. So I wonder if what happened here, because we got very close. Like we literally got every number except for 1. So what I'm going to imagine happened was while even, I'm going to copy this twice more. Don't kill me. Result dot push sorted even. While odd less, result dot push odd. Let's try this. That's the whole 44. Okay. Submit. Okay, hey, 50%, not half bad. But this is definitely not what you should be doing. Can we wait a second? Oh no, we can't just do this. Is like a weird merge sort type of thing. Like, how is this? I don't buy that. I did so much here. The bottleneck is definitely the sort, right? N log n. I mean, I have to create the array. But maybe there's a way that I don't even have to, because it would be nice to use. So I'm always getting, yeah, I think the hardest thing is, and I keep failing on this, but it's like, is it just the smallest even and the largest odd? Like, if that's the case, smallest even, and the smallest even is 2, but here the smallest even is 2 and the largest odd is 1. Oh, I see. Okay, so wait. Let's try something else. We're gonna go back to the original thing. We're gonna do const counts equals new array of 101 dot fill 0. Then we'll do for const n of nums counts of n plus or equals 1. And then we can say for let smallest even and the smallest odd, but it can also be smallest even and the largest odd. So it's like what I want to do is I want to go through counts, right? We can say let even equals 0, let odd equals counts dot length minus 1, while even is less than odd. So I want to find the first even, like while counts of even is equal to 0, we'll increase even. While counts of odd equals 0, we'll decrease odd. Right? Because I know, well, counts of odd equals 1, and I need to make this. No, it's fine. Counts is going to be some number. Okay. So, right, because now I know that whenever I get to the first even, that's going to be the smallest even. And the first time I get to counts of odd not equal to 0. No, but I also need to check while counts even is equal to 0. But I also need to make sure and even modulo 2 is not equal to 0, and even is less than counts dot length. And odd modulo 2 not equal to 1, and odd greater than or equal to 0. What I'm doing here is like, I need to find the first number in counts that there's at least one of, right? So that's what this is for. Then I also need to make sure that that index is even. So if it's not even, right, then I'll continue increasing it, even if this is true. So that's whenever I'll stop when I find a number that is equal to 0 and it's still less, yeah, something like this, right? So then I think what I can do here is I only want to, like, if I can do again, if even less than odd, I can just break here. But what I should be able to do here is if I have my result, const result is this, I should be able to do result dot push even and odd and then increase odd and decrease minus. I almost think that would work. That is awesome. Look at that. Look at that. If even is greater than odd. Sheesh. Even result dot push. So why doesn't that work? It's definitely something I messed up here. If counts even, while counts even is 0, that means there's not a, that means we haven't found a number there, right? And even modulo 2. Okay, let me just let's write this out here. 4, 1, 2, 3 is what we're dealing with. Let's say our counts array is like this, right? So we're gonna have 1, 1, a 2, a 3, and a 4. Even is gonna start at 0. Odd is gonna start here. Okay, so I want to find the smallest even. The smallest even should be 2, right? It shouldn't be this. So while counts of even equals 0, oh, you know what? This should be or, right? I think these should be or. Like counts of even is 0, so just immediately increase the even. Is counts of even equals 0? No, that's false. Even modulo 2. 1 modulo 2, yeah, that's not 0, right? So that's true. Not equal to 0, that's true. So we can also go up again here. Counts of even equals 0, that's false. Even modulo 2 not equal to 0, that's false. Even is less than counts.length. Oh, that's true. So like, because I don't want to, or even is greater. I mean, should that ever only want to increase even up until, because what if that just keeps going forever? Well, I guess I'll stop by the time I get out. Because counts of even equals to 0, that'll just be like an out of bounds. That'll be undefined. Even plus plus. And then here I'll do counts odd is equal to 0, or that's false, or odd modulo 2 is not equal to 1, right? 0, 1, 2, 3, 4. If odd modulo 2, 0 is not equal to 1, that's true. So we go down 1, right? This is our 2 and our 3. So now we push these. Well, even is less than odd, and then I can keep going if even. Now it shouldn't be if even is greater than odd. We shouldn't break there. Because even can be greater than odd. It's not that I want to break as soon as I get to the middle. I want to break once they're just like, if even is greater than counts.length, if even is greater than or equal to counts.length, or odd is less than or equal to 0, then break. Let's try this out. Of course. Oh man. Yeah, well, we kind of got there with this one, but what would happen here? Let's say we get to this piece, then we get to even, do this one again. Counts even equals 0. This is not 0, 1, 2, 3, but then we get here. Okay, that's cool. Even plus plus. Then we get to odd of here. If even is greater than or equal to counts.length, no. Break result.push even or odd. Yeah, why didn't we push that last one? That shouldn't break right there. Oh. No, I think this, while even is greater than, while even is while even is less than counts out length, and odd is greater than or equal to 0. Let's try this. This is fun, man. This is like true LeetCode Live right here. While even is less than counts.length, and odd is greater than or equal to 0. So I did 2 for loops, I equals 0 and j equals I plus 2. Then and if else with I equals 2. Here I swap nums less than nums j based on the if else. And you're saying that worked, Rashawn? Like, did you pass it? Result.push even and odd. Oh, I feel like, so even is less. Okay, we do +1 -1. We get to here. Const even 0 or even plus plus. Maybe this probably breaks here. Yup. 2 for loops, I equals 0 and j. I wish there was a way that you can like paste your code, but like a nice way to paste it. Because it'd be cool if I can also just like put it up on the LeetCode here and like try it out. So if I did 2 for loops, I equals 0 and j equals I plus 2, and if else with if I is 2, I swapped nums based on the if else. Discord. Yes, Discord, man. Genius. Genius, my friend. Look at this. Discord live. Where is... Yeah, I guess you can probably like DM me, or... Yeah, you can DM me or something else. I guess you can just like ping me or something. LeetCode live. Oh, I won't be able to hear you here. Well, I guess you can also drop it in the chat in LeetCode live here. Oh man, we used to do LeetCode live on this. This is where it originated from. Yeah, I guess I'll look at the solution you put up, Rashawn, and I'll probably end the stream there since we're just a little over the hour. Yeah, there's like this chat button that you should see. This is cool. I like that we're like on the Discord on the live stream. Nice. I mean, props to like your solution looks clean, man. This is good. Can I just run this sorted even? 2 3 4 1 2 1. Yeah, like, so we're doing here I is 0, I less than num size minus 2, j equals I plus 2, j less than num size. If I modulo 2 is 1, so if it's even, if nums I minus nums j, if nums I is greater than nums j, it's almost like I remembered you doing the swap before. I'm trying to picture how this works in my head. Like I'm trying to paint like a mental model. First you start the values present. 0 and j equals I plus 2. What's up, MMD? 4 1 2. If I modulo 2 is 1. No, we just swap 2 and 4. Okay. And then we go to the next one. I plus plus. Oh, and then 4 let j. Oh, so this is doing all the j's. Oh, this is almost like a bubble sort type of thing. I can smell all burned here. Like, are you saying we're like burnt out? Yeah, kind of burnt out. No, I'm not. I'm not burnt out. This is fun. This is fun to be able to do it like this. I think I see what you're doing. It's kind of like a bubble sort of thing. For 1, 2, 3, because then we do let j equals I plus 2. If I is equal to 1, 2. You said you were thinking hard. Yup. Nice. No, this is cool, man. Yeah, I mean, it's definitely like way nicer to look at than mine is. And I wonder if we can even do nums I, j. Can we do like the fancy JavaScript swap? Even though it does not look as nice. Like nums of I, nums of j equals nums of j, nums of I. I just want to see if this would work for like both of these here. Two, 1, 44, 44, nice. Nice. Yeah, this is cool, man. I mean, it's definitely like, it'll be quadratic time, but it's constant space. That's like a classic, like, for odd and the else is for even. Right. No, yeah, that makes sense. Yeah, these are like classic trade-offs, right? An algorithm that takes longer, like this one, it will take longer because quadratic, but then we save on space a lot. Like we're not using any extra space to do anything. Whereas my other solutions, I was trying to like make more use of auxiliary space to be able to reduce the time or do it like linearly. Those ifs are weird. First time seeing that. Oh yeah, this is just like a fancy way of doing a swap in JavaScript. Like you just take, you wrap the things you want to swap in these arrays, in this array, and then you just equal it to like the flipped version of itself. And then you get this. Yeah, it's pretty cool. Anyway, I think we're a little over the hour. So it's been like really rainy here in South Florida, so I want to take advantage of it still being a little bit light out and seeing if I can get like a little walk going for myself. I haven't walked in a while, and like on the days that I don't get to walk, it's not very fun. So thank you all so much for joining. I'm super stoked of like the progress. I mean, a couple days ago I made this, I guess I made this a day ago. I thought it was longer, where I made the video for 250 subs, but like since then we've already gotten 17 more, which is amazing. So like thank you all so much for the support. Again, I really hope that this has been beneficial to you all. I'm looking forward to getting to our next milestone of 500 subscribers. Like we're closer to that number than we've ever been, because like I've said, once I get there, I'll be able to start interacting with you all more through like the community tab. And I feel like I'm going to have a lot of fun doing that. I can definitely see myself being very active on community tab and getting like polls or asking you all questions about what you want to see, asking questions about questions of the day on LeetCode, just like anything. So it's pretty neat. So thank you all again so much for joining. We'll be back here again tomorrow. I know that like I've been a little bit finicky on the times. The reason I've been finicky on the times is because like these past 2 days, I have my schedule set for like 5 p.m. Eastern. And then like all of a sudden there'll be a meeting at work that is scheduled for like 4:30 or even 5 p.m. So I need to push it out. So I know I've been pushing out the streams like last minute, but just please bear with me and like just keep tabs on the channel, and you'll see like the time, and you'll see if it changes. I don't know if like if you, for example, if you ring the notification bell, I don't know if it will also notify you of a time change in the stream. But just keep in mind that like sometimes I do have to change it because of work, and that's just life, right? So anyway, thank you all again so much for joining. People who enjoy will watch and not complain. Right. No, you're absolutely right, man. And I'm glad that like no one has complained so far. The whole community has been awesome. So I really do appreciate you all being here. So with that being said, hope you guys have a great rest of your Tuesday, is it? I feel like sometimes time just escapes me. Have a great rest of your Tuesday, everyone, and we'll see you all again here tomorrow, hopefully at 5 p.m. Eastern, for another daily dose of LeetCode Live. Have a great rest of your day.